The lesson that I'm going to be teaching today is called the ambiguous case of the sine law. So the point of this lesson is to tell you if the triangle exists or not and how many triangles there are given an angle side-side. So you need an angle with a corresponding side and a side corresponding to the angle that you're solving for. So you could solve this by using the formula sine A over A equals sine B over B. So you'd be solving for sine B, and then depending on what the number is, it will tell you how many if the triangle exists or not and how many triangles there are. So basically, the cases are, there's case 1, which involves a triangle with an acute angle. If what you solve for is less than 1 but greater than -1, two triangles exist in that triangle. If what you solve for is greater than 1, then no triangle exists, and if it equals 1, usually to 4 decimal places, one triangle exists. There's also case 2, which deals with triangles with an obtuse angle. If what you solve for is less than 1 but greater than -1, one triangle exists. If what you solve for is greater than 1, then no triangle exists. There cannot be two triangles in a triangle with an obtuse angle because in a triangle only one obtuse angle is allowed to be there. So basically, I already have the sine law written. This is an example question for an acute triangle because it's less than 1. It's 40 degrees. So basically, sine A would be sine 40 over the corresponding side, which is 15 centimeters. You'd make this equal to sine B. Sine B is what you're solving for, so this angle right here. And then the corresponding side length is 5 centimeters. So basically, you'd multiply both sides by 5 to get rid of the 5 on this side. This will leave you with 5 sine 40 over 15. I already did this on my calculator and I got the answer 0.2. So if we look back at our cases, you could see for case 1, which involves acute angles, the number 0.2 is less than 1 but greater than -1. Therefore, we know that in this triangle, two triangles exist. This is an example question involving a triangle with an obtuse angle, 172 degrees. So that's your A value. So 172 sine 172 over the corresponding side, which is 25 centimeters, equals sine B, so the angle that you're solving for, or the number that will determine how many triangles there are, and if it exists or not, over B, which is the corresponding side length, which is 7 centimeters. So you'd multiply both sides by 7 to cancel this out. This will give you 7 sine 172 over 25. So I already did this and it gave me this number. So if we look back, we could see for obtuse angles, the number 0.04 is less than 1 but greater than -1, therefore one triangle exists. Therefore we know that in this triangle, one triangle exists. So yeah, that's basically the lesson.